Every day, local governments generate millions of digital records. From traffic sensors to utility bills, municipal data accumulates at a chaotic, relentless pace. Mayors and city councils are under immense pressure to deploy predictive analytics and foundation models to make sense of this information. But as this diagram shows, there is a massive gap between the messy reality of a city's legacy data and the pristine goal of an AI-optimized infrastructure. Focusing on the left side, we see the immediate problem. Municipal information is trapped in fragmented silos, packed with inconsistent formats and duplicate entries that instantly paralyze analytical systems. Conversely, the right side illustrates the operational requirement. An ideal system utilizes automated governance to standardize inputs, allowing optimized pipelines to deploy models securely. An algorithm's performance is limited by the structural integrity of the data it consumes. Attempting to deploy machine learning on top of unorganized inputs creates a direct conflict between the model's logic and the city's actual operational records. This blueprint diagram lays out the overarching architecture required to safely implement artificial intelligence at a municipal scale. Cities construct their own AI infrastructure chronologically. As this three-stage graphic illustrates, municipal records act as the raw building blocks for the final digital superstructure. We begin with data governance. This is the mandatory first phase, standardizing the raw blocks and ensuring a complete, secure set of materials. Only then can we move to model governance. This final phase guarantees that the resulting AI creation is structurally sound and performs its exact intended function. A municipality cannot skip straight to AI deployment. Attempting to build a complex software superstructure without governing the underlying data blocks guarantees immediate collapse. Before optimizing traffic patterns or analyzing public budgets, every city must answer one unavoidable question: how do we govern the pieces? This sorting mechanism illustrates the rigorous pipeline municipalities must build to extract value from their most important digital asset. Achieving the total visibility required for AI means executing this four-step data cleanup cycle: discover, classify, enforce, and catalog. Step 1. Discovery. Unearthing legacy records from decades-old unindexed servers in the dusty attic above is difficult. Step 2. Classification. The clean, modern arrays below tell the system exactly what kind of block, whether a financial or traffic-related asset, it is currently holding. Classification requires enforcing strict protocols. For instance, universally locking all date formats to month, day, year ensures that disparate departmental records can interact without triggering system conflicts. Achieving total data visibility across all departments eliminates blind spots. A machine learning model trains effectively only if it has a complete, accurately mapped dataset. Step 3 is enforcement. This is where broad civic guidelines are translated into automated, hard-coded rules to protect public records from misuse. This PII shield mechanism demonstrates an absolute legal mandate to protect personally identifiable information under standards like HIPAA and GDPR. As a sensitive record passes through, digits like a social security number are immediately masked into asterisks, resulting in a secure structural block. Step 4 is the catalog. As this digital drawer shows, data remains useless without proper context. By attaching comprehensive metadata tags like author, subject, and origin, the asset becomes instantly searchable for data scientists feeding a municipal large language model. This three-pillar diagram outlines the final result of Phase 1, a data foundation defined by non-negotiable standards. The infrastructure is now consistent, secure, and high quality. Exposing sensitive citizen records alongside public operational data is a preventable failure. Proper governance secures legal liabilities, transforming them into completely safe, AI-ready assets. We now enter Phase 2, model governance. Here, the secured data pieces are assembled into specific machine learning tools, visualized by this complex digital superstructure. Foundation models are dynamic systems, not static software. They require continuous, active structural inspection to prevent physical and logical deterioration. This diagram highlights three primary AI failure vectors. First is hallucination, where an unsupervised model invents false facts about city policy. The middle warns of drift, where changing real-world conditions cause the model to lose accuracy. The final node is bias, reflecting underlying structural defects. Unmonitored AI does not simply crash quietly. It actively disseminates errors, compromising public trust and municipal authority. System architects defend against these systemic deteriorations by actively employing continuous, high-frequency, automated performance tracking to monitor operations. This dashboard interface details the quantitative standards governing AI reliability. The precision gauge measures Rouge, scoring AI-generated summaries against human references. The center memory gauge tracks knowledge retention for factual consistency. Finally, the speed gauge monitors latency, tracking the precise operational speed of the model. This governance matrix synthesizes the entire architectural blueprint into a single operational framework. Looking at the top rows, we clearly see the distinct focus of the two phases. Data governance organizes and secures the raw infrastructure blocks, while model governance maintains the reliability of the assembled superstructure. The bottom rows reiterate the preventative actions demanded by each side. Masking PII and classifying data secures the foundation, while bias testing and latency measurement protect the active algorithms. Acquiring artificial intelligence software without implementing this specific two-phased governance matrix is a dereliction of civic duty. Executing this complex governance blueprint manually across every municipal department is impossible. The conveyor belt diagram illustrates how automation scales these processes. By instantly discovering and classifying data, cities can govern their entire digital footprint without increasing headcounts or operational complexity. As detailed in the text blocks, proper governance delivers a tangible return on investment. It allows municipalities to extract and monetize insights from previously dormant digital assets. This final isometric grid illustrates a fully governed, AI-optimized smart city operating with perfect structural integrity. The central requirement is absolute. Data governance provides the secure pieces, and proper model governance ensures the structural integrity of the results. Together, these systems form the non-negotiable foundation local governments need to protect public trust and manage an AI-integrated infrastructure.